Alright guys, so I am back in the office today and I'm actually doing a little bit of a throwback here. I'm going through a lot of my old, I'm on the computer here. I'm going through all these old video files that I've never got the chance to upload to YouTube, and I want to. So let's do it. Let's take a look at maybe some older videos here. This one in particular I think is from maybe April or May of last year. So let's see. Let's take a look. Hello and welcome back to the program. I know it has been a very, very long time and I apologize, but well, hey, I'm busy and I'm sure you are too. So I'm gonna try and make a short video. I have a horrible way with making my videos way too long, but I'm going to try and keep this one very short and concise. But before we get started, I want to say that if you are located in South Central Pennsylvania or you want to relocate to South Central Pennsylvania, we are looking for top-notch service techs and installers. So if you are somebody who considers yourself top tier and truly are top tier, we would love to talk to you. We just like everybody, we're short-staffed. We're not willing to, hire a dud, but we want somebody who is top game. So if that's something you're interested, reach out. We'd love to talk to you, and we'd love to have you part of the team. So moving on. This video, I want to talk about another video that I had put up on YouTube probably, well, honestly, about 2 years ago, and it was talking about sizing ductwork the correct way. Now, I will apologize. The video, if you go back to it, it's a very rudimentary video. The quality is not very good. I am not a videographer. I don't know anything about professionally editing videos. That is not what I do. Okay. My job is not to get you a quality video, it is to get you quality content. The actual stuff that's in the video is where the money's at. I don't have fancy lighting, I don't have a fancy camera. I'm just here to give you some fancy numbers and get your system designed correctly. So that's what we're here for, and that's what I want to talk about. I want to talk about some of the most common comments that I've gotten from that video and a lot of the emails that I've gotten from that video. So let's dive into it. Now, the video that we're talking about is how to size ductwork the correct way. And I'm just gonna, like I said, run down some of the common questions that I've received on this video. So one of the most common questions is, hey, why didn't you do a load calculation for that design? Well, the thing was, that video was not designed to do a load calculation. I have other videos that talk about actually sizing a system. That video was designed for sizing the duct part of the system. I'm not delving into load calculations on a room by room basis or even a building basis at that point. I was just taking somebody else's design that they had and showed you how they designed it versus how we are designing them. So that's what the video is about. Another one that I had gotten a few times was, hey, this video is way too long and you are making it way too difficult. And, well, the thing about that is it's not really meant to be easy. I mean, come on. If you want to do it the easy way, I do have another video about that, how to size ductwork the fast way. That is not what this one's about, okay? This is how to do it the right way. And guess what? The right way takes a little bit of time. So, it is what it is. If you thought this was going to be like an entry-level video, well, it's not. So, yeah, that's that. Another one, hey, what about turning vanes? And that's a really good point. Turning vanes are great. They're a really good alternative or something. They're really good to incorporate in I don't want to say a poorly designed duct system, but a system that you've got things that you've got to work around. I mean, I'm not the architect and I'm not the designer of the building, and sometimes we have beams that, well, we're not going to move for a duct, okay? Or we have to do something that is not ideal, and that's just what it is. That's the reality of working through a system. And sometimes using turning vanes are the solution to that. I know around here, most of our residential places, I mean, I couldn't tell you, maybe on one hand, how many times I've seen even a vane period in a residential application. I do run across them occasionally in commercial systems, but it's not really common. As a matter of fact, if you go to my local parts supply houses, you're not going to find turning vanes. They don't stock them. They don't have them. If you do order them, they're going to take a long time. So in the past, I've actually made my own turning vanes to make a system work. And I can show you that in another video, but not here. But turning vanes, great alternative. Another one was the discussion about flex and duct board and sheet metal and what's the best and why are you doing it this way, blah, blah, blah. Well, again, there's a lot of duct board out there. There's a lot of sheet metal out there as well, and there is a heck of a lot of flex floating around in applications that there should not be flex in. And in those applications, a lot of times you will find it that it is like an R4.2 when you need an R8 or even an R6. Just incorrectly installed, incorrectly utilized. But the reality of it is, these are materials that we're going to find out in the world, okay? Maybe your company only does sheet metal, and maybe you size everything right, but I guarantee if you're out there doing service calls, you're going to run into hack jobs, you're going to run into systems that are not sized correctly, you're going to run into systems that are used or that are sized using the materials that I talked about in this video. So you have to know how to size a system correctly with ductboard. You have to know how to use flex the correct way because it's out there, okay? If you get tunnel vision into using sheet metal, that's fine, as long as you're never doing service calls. If you're doing only installation and you just want to limit yourself and your company to doing installation, by all means, do it. But it's just really good knowing that how to utilize these other materials in a duct design. So again, another one, friction rate. Friction rate, that was a very common question amongst people who watch this video. What is an ideal friction rate, and how do I know if the friction rate that I come out to at the end of my formula is going to be acceptable? So as far as friction rate's concerned, well, we've got that good old ACA wedge, and you can see that right in the center of that ACA wedge, we've got that 0.1, and unfortunately, that is where everything kind of fell apart. Whenever ACA put out this wedge and they kind of highlighted that 0.1 just because it happened to fall in the middle of that wedge, that is where everyone has started sizing their systems. And again, if you want to do it, that's fine. Go ahead. But the video was meant to show you how to do it the right way. Now, let's just say that you come out to a friction rate and you find that it's outside of that wedge, or you're on the high end or the low end of that wedge. Anything within that wedge, I would say, is pretty much acceptable. But what we can do is, if we find we're on the edge of that wedge, or outside of the wedge, we can go back and say, maybe we ought to look at changing our dimensions a little bit, okay? Or maybe we should look at sheet metal, or maybe we need to look at adjusting our velocity or our flow rate through that duct to compensate for the fact that we are outside or close to being outside of that wedge. So, I mean, long story short, as long as you're within that wedge there, I think you're pretty acceptable in terms of a good system. Now it's just a matter of, will your system be able to be designed within, if we're using that friction rate that you figured out, will it actually work physically mounting it? That's just depending on your job. So yeah, then we look at the velocity. Okay, so I get a lot of people say, hey, what should my velocity be? And that's up to you. Okay, to sum it up, I want to keep my velocity as high as I can, okay, without making noise. I don't want to hear that air rushing through and becoming turbid inside of the actual duct. And I also don't want it to be so low that we are giving up or absorbing temperature from an unconditioned space. So if you've got a total duct system that's within conditioned area, it's not so much of an issue. I mean, we can really slow things down and you know, and use the entire building as our duct. Not to be confused with using a central return or like a drop ceiling as a return. That's a no-no. I don't want to do that. I'm saying using the whole building as a duct. Yeah, so we want to keep our duct velocities as low as we can, but we want to keep them as high as we can too. So finding a good average, you know, range in there is up to you, and that also plays into what material are we using. If I'm running sheet metal, I'm going to have to keep those velocities a little bit lower just so we're not getting the expansion and contraction, the noise that you hear coming through the system. Ductboard, we can really crank the velocity through that thing. So something to consider. So that's that. I did have a few people ask me about air handlers. Maybe I didn't make it very clear in the video, but air handlers, as opposed to a furnace evaporator coil combination. Furnace evaporator coil combinations, whenever we are accounting for pressure drop, we are accounting for every single component of that. Okay. Air handlers, on the other hand, they already, from the factory or from your manufacturer spec datas, will account for evaporator coils. Okay, so whenever you get a pressure drop associated with an air handler, it accounts for everything within the cabinet of that air handler minus anything you add to that air handler, such as a internal filter rack, or even if it's an external filter rack, whatever, or auxiliary heat kits. Okay, so if you've got a backup heat kit for a system, it doesn't account for that. Okay, something to keep in mind. Now, granted, how much pressure drop are you going to see across an electric coil? I'm going to say none. You're not going to see enough to skew the design if you forgot to say, oh man, I got even a 20 kilowatt heat kit. I forgot to put it in the design. It's not going to blow you out. So yeah, anything within that air handler is accounted for with the manufacturer spec. If you're doing a gas furnace with an evaporator coil, you have to count them separately. Done. Okay. So then I had a couple emails about, hey, should I do a ductless system or should I do a ducted system? And this could be a whole nother video. The benefits, the pros and cons to each one of these. You know, so years ago, it was kind of a joke. We would say that ductless systems are a short-term solution to a long-term problem. And at the time, whenever I started, I felt it was pretty true. Now, as the years have gone on, ductless has come a long, long way. From being a supplementary cooling source to a computer room, which that's what they were, to being able to condition an entire building. And now we've got, you know, VRF systems and all kinds of stuff that go along in that ductless category. So they are truly becoming a main, you know, contender for a standard conventional ducted system. Again, what are the pros and cons of each? That's a whole nother video, but ductless now is something that we can consider as far as a main heating and cooling HVAC type of system. So, but something to consider with that is if you need to have UV or if you need to have humidification, if you need to have like fresh air, okay, or you're planning on running some sort of an ERV, ductless really leaves you limited in that regard. Now a good benefit to the ductless over the standard ducted systems is efficiency. I mean, you can't compete with the efficiency of these things. Even, you know, like I started this industry in geothermal, and when we even look at geothermal versus a standard ductless system, I mean, come on guys. You know, and I know I might, you know, enrage some geo guys, but you know, I'm a big geo, you know, advocate. I'm a big geo guy, but you know, a geo system, we're cranking that whole thing up and blowing air throughout the whole system. What if I come home and I only need to run the bedroom? Well, heck, how are you going to compete with that? Even if you've got like a Climate Master Trilogy, you know, something 40 plus SEER. Compared to even a 27, 25 SEER rated ductless unit. I mean, you can't, I mean, you look at how many watts you're burning on one bedroom versus a whole house on a Trilogy system. I mean, you do what you want, but something to consider. So, ductless, what's better? It all depends on your application, really, honestly. So, yeah, that's that. So again, if we go back to that video, there was not a lot of information given to us in terms of, you know, even lengths. You know, how long is that duct? We have no clue. What kind of equipment are we using? That guy didn't even have a return on the thing. Okay, so some people said, well, maybe they're using a drop ceiling area as the return and blah blah blah. Well, that's unacceptable in my book. I don't know where you're, you know, I don't know what the code is in your locale. Are you able to do that? Maybe you can. I don't know. You know, is it a restaurant? I had a guy ask, hey, well, hey, maybe that thing's running in a restaurant. If you're in a restaurant and you see somebody using open plenum area above a drop ceiling as their return, I mean, seriously? Come on. I don't know what kind of restaurants you got in your area, but whatever. It's just unacceptable. So we're not gonna design a system that way. We're not gonna rely on a, you know, drop ceiling area as a return space, because come on, you know, the reality of it is, if you've got a drop ceiling, you've got mice. I'd love to see a drop ceiling that doesn't have, you know, mouse turds in it. I haven't found one, okay? You're gonna have it. So if you want to be eating your taco and potentially have mouse turds blowing out of the diffuser because you're using a drop ceiling as a return, by all means do it, you know? I mean, I'm not designing my restaurants that way, so that's up to you. You decide what you want to do there. And then, finally, one of my biggest questions was, hey, this video was way too long. Pen and paper is not the way to go. Why aren't you using a computer program? Well, to be completely honest with you, whenever I get a set of blueprints in and I am designing something, it's all going into the computer. I don't do any pen and paper handwritten calculations anymore. I haven't done them for quite some time. One, it takes me too much time. Two, the big one, this is the big reason why I do it on the computer, is for documentation. I can print out blueprints. I can take them to the job site. I have a professional set of plans there that we can work off of, and it is all documented. The liability still comes on me for being the guy who designed it, but there's also the help that we've got a, you know, third-party major software program in the mix. Okay, we didn't just willy-nilly pick numbers out of the air and design a system. Okay, we used software, we used a computer, everything is verified, it all meets Energy Star standard, it all meets, you know, whatever we need, like ACA, you know, whatever version we're operating under, it all meets the criteria of a properly designed system. So that's the big reason why we use the computer, okay? Now, that's not to say that you can't do this pen and paper, because I showed you in that video you can. We can do the load calculation, pen and paper. We can do the duct design, pen and paper. We can do manual S selection, pen and paper, okay? So if you want to do it that way, it's fine. You know, it's just a big time thing for us and a liability thing for us as to why we don't. But you can. So that pretty much sums up the most common asked questions regarding that particular video. Like I said, I didn't intend for this video to really, beat up this particular guy that it was based on, but it was just something I happened to come across on YouTube, and I was like, oh, come on, guys. And the problem was I saw it time and time and time again with guys, companies designing systems 0.1 inch and saying that this is a duct design. Come on. So it's not right. I feel that the manual D portion of our industry is the biggest issue in our industry. Okay, most houses I go into, unfortunately, their duct is not sized correctly, and maybe if it was designed correctly and sized correctly initially for what new equipment that we are putting in there, we're putting a 20 SEER heat pump in. It's very likely that it is not sized to handle what that 20 SEER heat pump is now requiring of air. So that's that. Okay. Another thing, if you are working on a project, whether you are a contractor, whether you are a project manager, or even just a homeowner that is looking to do something at their house with their HVAC system, I've had a lot of emails that can you do this for me? And I would love to be able to design every single every email that comes across of blueprints. I would love to be able to do it. I don't have the time or manpower to do it, but that is something we do. If you have a set of blueprints or even a detailed sketch of your project, that's something we can look at and we can send you back blueprints for. If you have any questions about it, feel free, email me, and then we will get you a price schedule back, to look at that. But unfortunately, it's not something we can do for free, just because it does take time. Even though we're not using pen and paper, still putting all of your building's information into the computer takes a lot of time. So if that's what you need help with, let me know. And if you have any other questions, feel free, reach out. I really enjoy reading the comments that come through and seeing what you guys think and hearing your input. But I'm just trying to help you out and trying to get things in the entire industry up to par. So again, I just want to keep this a pretty short video. If you have any questions, reach out. Otherwise, I will see you on the next one. And I've got a bunch of videos that I have made. I haven't got them in the computer. So maybe if you are an editor and you'd love to edit some videos, I got a job for you as well, full-time job. I really don't, because I don't make any money here. It's just something I do for fun. So I will catch you on the next one. Take care, guys.